this tutorial, no need to draw a rectangle that represents the room. Just draw a horizon line somewhere in the middle of your paper. Place your vanishing point. Now we're going to draw our first shape in one-point perspective, a cube. Let's not draw the cube directly underneath the vanishing point. That's going to create all kinds of confusing overlaps. Let's place it a little bit off to the side, like this. Cubes have square faces, so that's the first thing we're going to draw, a square face, right about here. And let's make our cube about 3 inches across. Here. Now we're going to take that 3 inches and create the height. Let's use our right angle for this. Everybody, make sure your lines are perfectly horizontal, perfectly vertical. I can't stop emphasizing, repeating that principle. It's a little bit like constructing a building where the walls aren't quite straight. At first, it might be okay, but once you start putting floors on top of your foundation, your building is going to collapse. So little by little, the problems in your drawing are going to increase, even if the lines are a little tiny bit off vertical and horizontal. Okay, let's get exactly 3 inches here. Once we have a number of verticals and horizontals drawn, I can use my ruler, right? So I'm lining up my ruler with vertical and horizontal. I no longer have to use my right angle quite so much. But if I can, I'm going to constantly consult my right angle, line it up with the edge of my paper. Okay, now we've got a square tile. Now we're going to start drawing our orthogonal lines, going back to the vanishing point. Now, no point in drawing them all the way to the vanishing point, just extend them by a few inches like this. Which leads me to another very important principle. When you're constructing forms in perspective, at first you have to treat them as if they're made of glass, as if they're clear. So these lines, which normally would not be visible if our cube was opaque, are necessary to its construction. We need them. Okay, so we've got lines going back in space. How far back do those lines extend? In observational drawing, that's something that we could measure. We measure the distance from here to here, we compare it to the height. The beauty of perspective is that we can calculate with absolute precision exactly how far back they need to go. Here's how this is done. We're going to draw a measuring point at the corner of our paper on the horizon line. Measuring point. Also abbreviated as MP. How do we use this measuring point? Here's how. Line up your ruler with the measuring point and the furthest corner away. Draw a line. Do you see how there's an intersection right here? That's where the back of the cube ends. So if I draw a perfectly horizontal line from here to here, that's going to give me a square tile. Now I'm going to draw a vertical line, perfectly vertical. Let's make sure. Now that's going to give me the top 2 corners of my cube. So the measuring point method, not just for square tiles, not for creating square grids, but also anytime you need to draw a cube, you're going to use your measuring point to do it. Now, hopefully, if my lines were perfectly straight, my corners will line up, and so they do. All right. The next step in the process is to reinforce the lines you could see if the cube was opaque. Reinforce the visible lines, thicken them up, make them wider, more visible. and erase out all of the lines that I've left in red. So I'm not going to leave these in red though. These are visible lines. Okay. So this is how you construct a cube. If you need to see this again, rewind the video and look at it one more time. But let's move forward. Now we're going to construct a slightly more complicated shape out of this by stacking a second cube that's a little bit smaller right about here. Now that cube is going to be 1/4 the size of this one. How do we do that? Well, the first thing we're going to do is divide the top tile into 4 even increments. You guys remember the windows. This is the even method for constructing grids. We're going to start with a zigzag that looks like this. Then I'm going to find the center, divide that center orthogonally. Then get a horizontal division that looks like this. And now I'm going to take one of these tiles and build a cube out of it. Let's use the back left tile. So here's the width of the tile on the bottom. We're going to take that width and build a square out of it. Let's measure it. How big is it? It is a little bit larger than 1 1/4. Okay. Let's take that measurement and get the height of my cube. There's the height of my cube. Let's use red for this because these are all construction lines. Okay, here's the width of my cube. I didn't extend it quite far enough. Close. Okay, so here's the square tile, the square face. Now we're going to extend lines going to our vanishing point. And 2. And now I no longer need my measuring point because I know exactly how far back our tile, our square face needs to extend. Here we go. Here we go. And now if I connect my 2 back corners together, I will have a cube. This is going to be really thin because the top of the cube is very, very, very close to the horizon line. But we can still see it. If I drew the first cube a little high, we'd push the second cube either to the horizon line or over it. Not particularly important. It's just going to have a different look to it. Okay, so I've created a slightly more complex form. This is something called the additive method of construction. We take a bunch of simple forms, we stack them one on top of the other, or glue them next to each other, and create something increasingly more complex. This mimics the way things are actually manufactured. So if I was going to build a table, probably one of the first things I would do would be to find a large plank, a door, like this, and then attach some legs to it. Okay, I know this leg's not quite in the right place, but that's the idea, right? So basically, starting off with a flat box, a door, and then adding long tower boxes to it. This is called the additive method. I'm adding on. Additive method. There's one other way of creating more complex forms, and that's called the subtractive method, the taking away method. It involves taking something simple like a cube, a block, and then carving shapes into it to create things that are more complex. So let's use the subtractive method here. We're going to carve a cube into the larger cube. That cube is going to be the same size as this one. It's going to be 1/4 the volume of the larger cube. Let's start by finding the center of the front face of the cube by using the zigzag method. Now, I don't have to run lines all the way across. I can just make a little X to mark off the spot. That's going to limit the amount of construction lines and prevent us from getting overly confused. Now, you guys should have erased these construction lines, but I wanted to keep them so you guys can see the process. Here's the center of the cube. Now we're going to create 4 even panes. Let's divide our cube this way. Divide our cube this way. Let's make sure these lines are actually straight. That would be helpful. All right. Okay, so we've got a square tile here. Now we're going to, let's move to red. Find where these 2 lines connect. So essentially we're drawing a cube here. So from here, we're going to run a line to the vanishing point, like this. From here, we're going to draw a vertical line. Okay, can you guys see that I've drawn a cube here? Hopefully you can. Let's reinforce this slightly. Okay, so here's our cube. Now we're going to start connecting our 3 corners together. This corner, this corner, this corner to create the depth. Let's use our red construction pen. Again, guys, you have to stay really focused when you're doing this, because if you start going a little bit off, little by little, you're going to run into problems. So I'm trying to be as accurate as possible. Now we're going to connect our corners together. Okay. Now we're going to drop a vertical line down. And now, I know it's a little bit hard to see, but we've carved a cube into the larger cube. Let's reinforce our lines a little bit so you guys can see this. Here it is. At this stage, I'm going to go over the entire drawing, reinforcing visible lines, erasing invisible lines. These 3 lines here are no longer visible. You can erase them. They should be gone. And then let's reinforce the top cube so you guys can see it more clearly. Again, the top of the cube is very, very, very thin. I'll try to use a thin line there. Okay, so this is the subtractive method. I've carved a cube into it. Another really common method that mimics the way quite often things are constructed. So in the subtractive method, I would start off with a solid block of wood, like this, and then carve a table out of it. Which method is best? Well, it depends on what you're doing. Quite often you can use either one to achieve exactly the same effect. But most often when you're doing perspective, you're going to use both together. So that's something we did here, and that's something we're going to do in our later projects. This is the subtractive method. two ways of constructing complex forms in linear perspective.